Yes, guys. So we are doing question number 9 now. Okay, ninth question is regarding what are the reciprocal trigonometric relations. Reciprocal. What are the reciprocal relations or reciprocal trigonometric relations? Okay, so let me take question number 9 now. Question number 9 is reciprocal trigonometric relations. Reciprocal trigonometric relations. Let me take. What are the reciprocal trigonometric relations? That's the point of today. Now, question number 9th. See, I've discussed about question number 10th. Again, I'll take this, no problem at all. But what are the reciprocal relations? Reciprocal trigonometric relations. T relations. Trigonometric relations. The reciprocal trigonometric relations that we have discussed. Okay, we have discussed about what are the trigonometric ratios or functions or circular functions, relations in other trigonometric relations. Okay, that I have discussed in detail. Now let me take question number 9. So trigonometric. Now we know that there are 6 trigonometric relations or trigonometric ratios. What are those 6 trigonometric relations I have just talked about? Number of times I have talked about sine of angle, cos of angle, any angle. Okay, then tan of any angle. Then 3 more are there which are reciprocal, which are known as reciprocal of these. Or there are 3 pairs of reciprocal relations. What is reciprocal means? When, let me take, when multiplication of any 2 functions, now in this case trigonometric functions or relations, multiplication of any 2 relations or functions or relations, especially trigonometric relations, is equal to 1, is equal to 1, then each relation or function, then each trigonometric relation or function is known as a reciprocal relation. Reciprocal function or relation is known as a reciprocal function or relation. The reciprocal function or relation. Okay, so for example, now we know that from a right angle triangle, as I discussed number of times, if this is right angle triangle, by Pythagoras all we take, let me take this as ABC. Now any angle which we consider, suppose this I consider angle CAB as theta angle. Now we have to find out trigonometric relations of this angle. Sine of theta, cos of theta, tan of theta, secant of theta, cot of theta, tangent of theta, okay, or cosecant of theta or secant of theta. So that is defined in terms of sides. What are these sides here that we know about? What are sides here? This is because the side opposite to the angle which we consider is known as perpendicular. This always be case. Perpendicular, the angle which we consider, the side opposite to that is known as perpendicular. Okay, and this is the base. The other side, the 2 sides make the right angle. The 2 sides which make the right angle, are either base or perpendicular base, or it depends upon the angle which we consider. Suppose if I consider this angle, and this is now 90 minus theta, if I take sine 90 minus theta, then what is sine of angle? Perpendicular upon hypotenuse. This is the hypotenuse which is the side opposite to 90 degree angle, or this is 90 degree angle, right angle triangle, and this is the hypotenuse we know about. This is not changed. This is not changed. Hypotenuse. So the hypotenuse is not changed. Only these 2 sides are changed. It depends upon the angle which we consider. Now here we are considering this angle A to angle A, the side opposite to this angle is perpendicular, the other side is base, and the hypotenuse is not changed, so hypotenuse remains unaltered. So this is hypotenuse. Now, in terms of these sides, perpendicular angles, I've already defined that what is sine of theta. We know that sine of this angle theta, or this is complete name is sine, SIN is sine of theta, or equal to, we write in short sine theta, which is equal to perpendicular upon. I defined that shortcut formula. Okay, PP, that was PBP divided by HHB. That means perpendicular upon hypotenuse, base upon hypotenuse, perpendicular upon base. First is sine theta, this is cos of theta, this is tan of theta. Okay, and this is remembered by the students in number of ways. Okay, in shortcut or in taking dialects, Indian dialects. Okay, what is that? Pandit, Batri, Kasar, Har Bole. This is in North India, and in Delhi itself there is Pakistan, Bhuka Pyasa, Hindustan, Hara Bhara, Hindustan, Hara Bhara, Pakistan, Bhuka Pyasa, Hindustan. This is patriotic type of tone which the students believe. Okay, they remember in this way. I came to know from this, about this from the students. Okay, and they told me, sir, this is what is remembered in Delhi itself. Okay, so in Delhi, from this I came to know about the Pandit, this Pakistan, Bhuka Pyasa, Hindustan, Hara Bhara. So this is how P upon H sine of theta, B upon H base upon hypotenuse, perpendicular upon hypotenuse, perpendicular upon base. So this is, I have told you about, this is tan of theta, this is cos of theta, and the first one is sine theta. Here it is perpendicular upon hypotenuse. This is shortcut the students remember. Okay, perpendicular upon hypotenuse. Now what is cosec of theta? Now cosec of theta, which is just opposite to secant of theta. Okay, to secant theta or cosec theta, we thought right, cosec theta. This is hypotenuse upon, just opposite of this sign. This is hypotenuse upon perpendicular. Now if I just multiply these two, that means sine of theta into cosecant of theta is equal to how much? Let me write sine of theta means perpendicular. Let me write this P upon H, and this is H upon P. So H is cancelled out, PP cancelled out, this is 1 only. So these two are reciprocal of each other. What are the reciprocal relations? We say that sine theta and cosecant theta are reciprocally related. They are reciprocal to each other. So their multiplication is equal to 1. When the multiplication of two relations or two functions is equal to 1, then each function or each relation is known as the reciprocal to each other, reciprocal of each other or reciprocal to each other. That is how reciprocal is considered. There are 6 trigonometric relations. Out of that, 3 are reciprocal of other 3. So let me note down what is the reciprocal of each relation. Reciprocal of each relation I'll talk about. First is sine of theta. Reciprocal is cosec theta. I have just talked about sine of theta, or we write simply sine theta, which is perpendicular upon P upon H, and cosec theta, which is just opposite to secant of theta, or equal to cosec theta. Shortly we write this is H upon P. So here we see here sine theta into cosec theta is equal to 1, or sine theta is equal to 1 upon cosec theta. Reciprocal can be written like this, or cosec theta is equal to 1 upon sine theta. So sine theta and cosec theta are reciprocal of each other. That means reciprocal. Now these are the first 2 relations I have taken. Other 2, let me take cos theta. Okay, this is cos theta or cosine theta. This one is cosine theta, or simply write cos theta. This is cosine theta, cosine of theta. right? Or cos theta simply. This is b upon base upon hypotenuse. And secant theta is the fourth one, or this is secant theta, or simply we write sec theta. Okay, this is h upon b, hypotenuse upon base. Okay, so multiplication of these two we see here. So here we see this, these two imply that cos theta into secant theta is equal to 1. So secant theta is equal to 1 upon cos theta simply, and cos theta is equal to 1 upon secant theta. These two are reciprocal of each other. Cos theta, secant theta are reciprocal of each other. Sin theta, cosec theta are reciprocal of each other. Similarly, the fifth and sixth one, which is, let me take tangent theta. Tangent of theta, or simply we write tan theta, which is nothing but p upon b, perpendicular upon base in the right angle triangle, perpendicular upon base, and cot theta, or this is cotangent theta. Cotangent, this is only cotangent theta. Cotangent theta, cotangent. Okay, or we write simply cot theta. Cotangent theta or cot theta we write. This is v upon e. With this imply that tan theta, or let me take cot theta. Cot theta is equal to 1 upon tan theta. We multiply them, or tan theta is equal to 1 upon cot theta. These two are reciprocal of each other. Cot theta and tan theta, they are reciprocal of each other. Secant theta and cosecant theta, they are reciprocal of each other. Sin theta and cosecant theta are reciprocal of cosec theta, are reciprocal of each other. These are 6 trigonometric relations. After that, there are 3 pairs of relations which are reciprocal to each other. Okay, so this is how reciprocal relations means 9th question is completed. Okay, these are the basics of trigonometry we are talking about. After that, I'll take the higher chapters which are, because the basic knowledge is must, okay, for the students. Otherwise, we cannot solve the questions which will be discussed in the next lecture series. Okay, so because of that, I'm taking the basics of trigonometry, which are very important, are taken from students' studies. But sometimes the students do not remember the trigonometric identities or trigonometric formulae or trigonometric relationship. That's why I'm taking the basic points. Okay. Now let me take question number 10, which I have discussed, but let me again take it. What are the trigonometric relations or ratios in terms of coordinates? Okay. So if I take in coordinate geometry, we know what the coordinate geometry. This is question number 10. Let me take 2-dimensional geometry here. This is O, origin, x-axis, y dash axis, and this is x dash axis. If I take a point P, let me take, of coordinates x and y, x coordinate x, and this is x and y. Now, if I draw perpendiculars from this and join O to P, okay, and this is suppose A point. This is x coordinate, this is y coordinate. Let me take this r is equal to 1. R is, we have taken this length OP is equal to r, which is equal to 1 unit. Okay, so this is question number 10. Let me take question number 10. What is the sine of theta? If this is theta and if I take, in sine of theta we know perpendicular upon hypotenuse. This is right angle, because we drop the perpendicular from P to this, and which means the axis that A, this is right angle, 90 degree angle. Okay, 90 degree angle. Now, so therefore, sine of theta, how to express the trigonometric ratios in terms of coordinates. Here x and y coordinates are there. Okay, and as I discussed about this hypotenuse by Pythagoras theorem, we know that r square, or that OP square equal to OP square equal to OA square plus this PA square. Okay, or OA square, PA square, let me take like this. Okay, so this is nothing but x square plus this y square, or r is equal to square root of this by Python, if I take square root of this right hand side, this x cubed plus y square, we can express them, but this is equal to 1. We are taking this r is equal to 1 in this case. But if we replace r by, if r is not equal to 1, then r is given by this x square plus y square. Okay, so square of these other two sides, so square root of that. Okay, sum of the squares of the other two sides, and then square will give us the length of this side. Okay, so b r is equal to 1 root x cubed by square. In terms of coordinates, so in terms of coordinates, we have to find out in terms of coordinates. In terms of coordinates, expressing the trigonometric equation. What are the trigonometric equations in terms of coordinates? Okay, coordinates. The trigonometric ratios I'm talking about. The trigonometric ratios or relations. Ratios or relations are expressed as follows. As follows. Number 1, if I find sine of theta, now I will write short sine theta, which is perpendicular upon base, that means y upon x here. Theta, side opposite to theta, the angle which we are considering, is perpendicular, so perpendicular upon hypotenuse. And sorry, p upon r, I'm sorry. P upon r, this is y only, because y upon r is 1 here, only this is y coordinate, sine theta. Cos of theta, second one, is equal to x upon r, or x upon 1, which is x only. This is the first, second equation I have taken. Then the third one, tangent of theta. So tan theta is y upon x only. This is y upon x, only y upon x. Okay, so in terms of coordinates, y upon x is tangent theta. This is third equation we have taken. So in terms of coordinates, we have to express. And if I take r is equal to this, we can replace r by this. So if r is not equal to 1, then this is equal to, we can write under root x to by square also in place of this 1, because 1 is equal to this, or r is equal to this. Okay, now fourth one, we take cosecant of theta or cosec theta. Cosec theta is this reverse of this sign. So this is r upon y. R is 1 upon y is fourth one. Now fifth one, let me take secant theta. Secant theta is just reverse of or reciprocal of cos theta. This is 1 upon x here, or r upon x. R is 1 basically, or r can be written like this, and 2 x square y square upon x. That is 1 upon x only. So this is the fifth one. Now sixth one, cot theta or tangent theta, cotangent theta. This is cot theta. Cot theta is based upon, sorry, perpendicular. This is based upon perpendicular, but I am writing in terms of tan theta. This tan theta y upon x. This is here x upon y. Just reverse of this. We write this as x upon y. So in terms of coordinates, we can express these trigonometric relations like this. Okay. We take in first quadrant, in third quadrant, fourth quadrant, fifth quadrant. As we see that in the first quadrant, all the coordinates are positive, and x and y both are positive. In this second quadrant, x coordinate will be negative, y will be positive. But in third quadrant, x and y both will be negative, because y axis is negative. Below this origin is this axis. Below x axis, y axis is negative. Above y axis positive. Sorry, y axis positive. Y coordinate will be positive. And then, so in the third quadrant, x and y both are negative. In the fourth quadrant, x positive, y negative. In that way, coordinates can be replaced. Okay, so the relations, trigonometric relations, can be found out in this way. This is what question number 10 are discussed about. Now let me talk about next question. The question number 11. What did you say? Let me talk about question number 11 now. Now question number 11 says, what are the even and odd functions? Let me talk about. odd and even function. Odd and, what are the odd and even functions? Odd and even functions. Okay. Now in coordinate geometry, as we were discussing about. Okay. Now if I take, this is the right angle triangle, as we discussed. This is angle theta. This is angle theta here, and just opposite, below this, we draw angle, okay, line, just equivalent to this. This is O P. Let me take, this is P dash here, and if I just take this line just below this, and this is P dash here, and this angle is this, then is minus theta. Why? Because we measure this angle anti-clockwise, positive, and this is now negative because this we are taking clockwise. This is clockwise. So this angle is negative, minus theta. This is positive theta. Now, if we find the trigonometric ratio of any negative angle and it still remains negative, means if sine of minus theta equals minus sine theta, it becomes negative, then we will say that this is odd function. So even functions remain same positive even if the angle is negative. So even function, odd function, let me write here. We will just calculate all the 6 trigonometric relations and we will find that which are the odd functions, which are the even functions, will depend upon this. Now if I take, this is y coordinate, this is x coordinate. Now here it will be minus y. Why? Because this is y coordinate negative, and this is r. We have taken r here. R is not changed. Okay, r is the same length. R is positive here. R is positive. Y is negative. Here it is minus y. But x, this x coordinate is positive. X coordinate is positive, but y below x axis is negative, as I just described. So, and this is x dash, y dash, y and y dash x. This is in coordinate geometry. Now come to point. So, if I find this negative angle minus theta, if I find sine of that angle, cos of that angle, then let me just find out what is that value. So, if let me try define this. What is the definition of odd and even function? If trigonometric relation of an angle, okay, negative angle in this case, of a negative angle, okay, is negative, then it is known as an odd function. Then it will be an odd function, or it is known as odd function if trigonometric relation of a negative angle is positive, then that function or relation will be known as even function. So what is odd and even means? Now let me define from this figure, okay, from these figures. Now if I find out this is, let me take A. So in triangle OAP, let me take in first OAP. All are even function or odd function. So in triangle OAP and triangle OAP dash, what we see in OAP, sine of angle theta is equal to y upon r. But sine of angle minus theta, or in triangle OAP dash, sine of angle minus theta means below this triangle is equal to minus y upon r. Equal to minus y upon r. What do we see here? If I take minus sign common, this is y upon r. Y upon r from first is sin theta, this is minus sin theta. Similarly, if I find cosec theta, in that also this 1 minus sin will be there. That will be negative. Similarly, right here. Similarly, cosec of minus theta is equal to r upon minus y. So this is equal to minus r upon y, which is nothing but minus sin cosec of theta. So the r upon y in the first triangle test, cosec of theta equal to r upon y. This is minus cosec. So negative of angle cosec of minus theta is minus cos theta. It is odd function. Okay, hence let me write here. Sin theta and cosec theta are odd functions, and these two are odd functions, as sine of minus theta equal to minus sin theta and cosec of minus theta equal to minus cosec theta. So these are odd functions. So negative of trigonometric ratio of negative angle is equal to negative of that trigonometric function is odd function, or are odd functions. They are known as trigonometric functions but odd functions. So sine and cosec, these are odd functions. Sine and cosec are odd functions. So sine and cosec, these means sine and cosec. Yes, sine and cosec are odd functions. Alright, now let me take cos theta. But cos theta is equal to, if I find from first one, you need x upon r in triangle OAP or OPA. Let me take. But cos of minus theta is equal to, still it is based upon perpendicular, x upon r same in triangle. Let me write here, in triangle OP dash A minus theta, because minus theta is in triangle, but still it is positive with x upon r. This is nothing but cos theta. Okay, similarly, secant theta is equal to r upon x in both the r minus theta or equal to r upon x is equal to, let me take, equal to secant of minus theta. Secant minus theta is equal to r upon x equal to secant theta, same. Both are same thing. Therefore, these two are even functions. So, what we see here, they are positive. Even if we are taking negative trigonometric ratio of negative angle, but they are positive. Hence cos theta and secant theta are, or cos and sec are even functions. As negative of angles, their values are positive, are even functions. Cos theta and cos and secant, cosecant and secant Yeah. So secant and secant are, this is cos theta, cosine theta. This is cosine theta and secant theta. Cosine theta and secant theta are even functions. Okay. So these two are even functions. But now let me take tan theta, and tangent of theta is equal to y upon x in triangle OPA. But tangent of minus theta is equal to y upon this minus y upon x. This is minus y upon x equal to minus y upon x, which is minus tan theta. Now this is in triangle OP dash A. OP dash A. So here negative of tangent of negative angle is negative. Okay, is negative of trigonometric ratio. So it turns negative. Negative of tangent angle, tangent of negative angle is negative. Is turned negative of tangent theta, of tangent function. This function is odd function again because it is also negative. Similarly, cos theta and cos theta is also this x upon, in the first triangle it is x upon y, in triangle OPA, first triangle, above triangle, and cot of minus theta is equal to x upon minus y, that means minus x upon y. Okay, so that means, okay, that means this is minus sine cot of theta, minus sine cot of theta. This is in triangle OP dash A. OP dash A. What we see is negative. These two are also odd functions. What we see here, hence these two are negative of functions. They are odd functions. Hence tangent and cotangent are odd functions because they turn negative, are odd functions. Hence, out of the 6 trigonometric relations or ratios, 4 are odd functions and 2 are even functions. So, out of